Today, I'm using Linux as my operating system, and I'm using the gedit editor, which I like quite a bit. As we've stated previously, every program must have an end statement to it. You can also say end program for emphasis. Also, optionally, you can have a program statement at the beginning. Our first task is, how do we declare integer variables? We say integer space, then two colons, and then any list of integers that we wish to define. Strictly speaking, the two colons are not absolutely necessary, but put them in anyway for reasons that will become clear later. I have declared integers I, j, and k. I is going to be set equal to 6 while j is 5, and I'm going to print out the value of I plus j, I minus j, I times j, and I divided by j by doing the arithmetic, storing the result into variable k, and then printing it out. Obviously, I should get 11, 1, 30, and I divided by j by all rights really ought to be 1.2, but we'll see about that. We see the 11, the 1, and 30 as expected, but we don't get 1.2 for I divided by j because these are integers, and integer division will get truncated, so only the part in front of the decimal point has a chance of showing up. A common looping mechanism in Fortran is the do loop. Its syntax is do, and then some sort of iterator, I in this case, equals, I'll have two literal numbers there, 1 and 100, do I equals 1 comma 100, and then some action or the other to be done. In this case, I am adding I to the value of k, storing it into k. The loop ends with end do, and then I'm going to print out my k value here. Since I initially set k equal to 0 and have gone from I values 1 to 100, adding I to k at each iteration, what should be sitting in variable k when it's printed out is 1 plus 2 plus 3 out to 100. This will be 5050, which of course is what we get. We can add things up in reverse order if it was convenient for us to do so. The syntax is do I equals what I want the beginning index value to be, so I will start at 100 here. We will look at values as small as 1, and every time we go through the loop iterator, the I, will get decreased by 1. Of course, this is going to give me precisely the same answer the other one did, but it's just an exercise. We get 5050, as we should. I'm coming up very close to the 5-minute mark here in terms of actual material, so I'm going to save floating point work for the next video. I hope everyone has a good day. I'll talk to you again soon.